Good morning to all. Introduction of Engineering Mechanics, delivered by Elavarasan, Assistant Professor in Mechanical Department, SAT. What is mechanics? Mechanics is a branch of physical science which deals with the states or the motion of bodies under action of forces. Mechanics is divided into two, that is statics. Another one, statics. Statics is equilibrium of bodies under action of forces. Another one, dynamics. Dynamics is a study of motion of bodies. Under dynamics we have divided into two, that is kinematics and kinetics, and lots of. Is a one of the rigid body we consider. In the rigid bodies, force 1, 2, 3, 4, 4 forces are acting at the same point. This is one of the example. When we consider kinematics, we consider only particles and rigid bodies. Statics, mechanics, still went to these forms. Mechanics we can use in structures, automotives, robotics, spacecrafts, memes, etc. Statics, and it divides into statics, dynamics, mechanics of materials, fluid mechanics, vibration, fracture mechanics, etc. Basic concept definition. Space, collection of points whose relative positions can be described using a coordinate system. Time for relative occurrence of events. Space of points, collection of points whose relative positions can be described using a coordinate system. So relative for a time. Mass, resistance to change in velocity under dynamics. Quantities that influence mutual attraction between bodies. Particle, a body of negligible dimensions. Rigid body, body with negligible deformations. Non-rigid body, body which can deform. Before considering the whether body can be assumed rigid body or not, you need to estimate the relevant force first. In statics, bodies are considered rigid unless stated otherwise. Force is a vector quantity that describes an action of one body on another. In dynamics, force is an action that tends to cause acceleration of an object. The SI unit of force magnitude is a Newton. 1 Newton is equal to 1 kilogram meter per second squared. Scalars associated with magnitude alone: mass, density, volume, time, energy. Vectors associated with magnitude and direction: force, displacement, velocity, acceleration, like that. Force is a vector quantity. It's able to have direction and magnitude. It's also direction. Mech vector also. Vectors have magnitude and direction. So what are the directions? How much is the magnitude? It's not equal. Internal effect stresses will be generated. External effect affected. Point of application is main. The external consequences of the two forces will be the same if rigid body. This is fixed vector and this is free vector, that is sliding vector. Force on rigid body. Point of action. Force on rigid body. Sliding vector. It's a free vector. Rotational motion, couple, both will be active. Rotation vector. See this. Rotational motion occurs every point in the object. Principles of transmissibility. The forces can be considered equivalent if we concern only about the external resultant effects on rigid body. We can slide the force along its line of action. The forces may be applied at any point on its given line of action without altering the resultant effects external to the rigid body on which it acts. Physical quantity of vector, which already we discussed. Vector representing physical quantities can be classified: fixed vector, sliding vector, and free vector. Principles of mechanism: parallel law, the law of principle of transmissibility, Newton's first law, second law, third law, and law of gravitation. The two vectors v1 and v2 treated as free vectors can be replaced by an equivalent v, which is the diagonal of the parallel formed by v1 and v2 as its two sides. Generally, v is not greater than equal to v1 plus v2. If there are not free vectors, you can assume them if and only if they have the same point of application. Two forces can be considered equivalent. We consider only the external resultant effects on the rigid body. Summations: concurrent forces, non-concurrent forces, their sliding vectors. Newton's law of motion. First law: an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and the same time unless acted upon by an unbalanced force. It is summation of f is equal to 0. Next, second law. The acceleration of a particle is proportional to the vector sum of the forces acting on it and its direction of its vector sum. F is equal to ma. And then third law. The mutual force of action and reaction between two particles are equal in magnitude and opposite direction and collinear. See this picture. F reacts and opposite. Fixing. Isolate the body. Concept of free body diagram. Force always occur in pairs, equal and opposite action reaction forces pairs. Newton's law of gravitation. Capital F is equal to G. G represents the universal constant of gravitation. R is the distance between the particles, and capital N is the particle of motions. For a gravity on Earth at sea level, W is equal to mg. M is the mass of the body in equation, and G is a capital M over 9.81 meter per second square.